right, of that function, 1 to x. So g of 2, you just plug in 2 into that. So g of 2 is just going to be the integral from 1 to 2 of f of t dt. So that means the area under the curve from 1 to 2. So you're going from 1, x equals 1 right here, all the way to 2. You need to find the area of this right here. Anybody have that area right there? Is it going to be positive or negative? Negative is a triangle with a base of 1 and a height of a half. A half times 1 times a half. What is that? Negative what? Negative 1/4. A half times 1 times a half. Negative 1/4. Good. The next one says g of negative 2. So are we scanning from left to right or right to left on this one? We're going from 1 to negative 2 of f of t dt. If you really want to go the same direction, what don't you like about going from 1 to negative 2? It's going from right to left. We really like going from. So if you really want to, what could you do? You could change it to negative of negative 2 to 1 of f of t dt. Is that okay? Sure. Let's just go from negative 1, which is right. Nope. Sorry. Wrong one. Was it negative 2? Yeah, we got it right. So we need this part right here all the way to where? All the way to here. So what's the area of this thing right there? What's the base of that thing? What's the height? And it's half of it, right? Oh, 1/2. What is the base? 1, sorry. And what about this one right here? That's pi r squared. What's the radius? All over what? 2, but because it's below the x-axis, it's going to be what? Negative. So what's this going to be? It's going to be 3 over 2 minus pi over 2. That's it. The key mistakes are just really, 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 really easy math mistakes. What? What's wrong? Oh, I see. Look, hold on, look. What did we forget? The negative sign. I just said the mistakes are making simple math mistakes. What did we factor out? We factored out the negative sign right there. It better be right there as well, right? So what does that turn it into? Pi over 2 minus 3 over 2. Look at that. That was totally self-fulfilling prophecy. As I was saying what the mistake was, I was making that mistake. Isn't that awesome? Good job. Good catch. Okay, we good so far? Find them. Find them. For each of them, find the value or state that it doesn't exist, right? Well, what is g? G of x is what? Do you remember? Is the integral from 1 to x of f of t dt. So what is g prime of x equal to? No. F of x. What is g double prime of x? Prime of x. So what do we know? Therefore, this tells us that g prime of negative 3 is equal to f of, and we go look at our graph right there. What is f of negative 3 going to be equal to? F of negative 3 is equal to what? There it is. You had to actually plug it in, but yeah, equals 2. And then what does this tell us? G double prime of negative 3 is equal to f prime of 3. Negative 3, sorry. And what's the slope there? Just 1. The slope there is 1. You just have to read these carefully. That's it. Just read it carefully. Look what it says. Find the x-coordinates of each point at which the graph of g has a horizontal tangent. So let's just stop there. Horizontal tangents. What is true about a horizontal tangent? Slope is what? So you know the derivative is 0 there. Well, we know that g prime of x. What was g prime of x equal to? Was equal to f of x, right? So we're looking for when f of x is equal to 0. We look at our graph. Where is f of x equal to 0? Negative 1 and positive 1. So you know that this is true when x is equal to negative 1 or what? Positive 1. G prime is f. Where is f 0? F is 0 at negative 1 and positive 1. Now it says for each of these points, determine whether g has a relative minimum, relative maximum, or neither. What are our tests? There are 2 different tests we could run to find out if it's a relative min or max or neither. What's the first test you learned? The first derivative test. There's also the second derivative test. Let's try the first derivative test. We know that's horizontal tangent. That could mean 3 different things. It could mean going up and then going down. It could mean going down and then going up. Or it could mean rising stops for a second and keeps rising, or falling stops for a second and keeps falling. Like x cubed, the derivative of x cubed at the origin is 0, but is it a min or a max? No. Having a derivative of 0 is necessary for it to be a relative min or max, but it's not sufficient. It's not sufficient. You need both of these things. So let's do the first derivative test. So if we do the first derivative test, we need to look at f what? F prime of x at what? At x equals -1 and x equals 1. Actually, around these values, right? So let's look at these. Let's look at this. We have -1 and +1. Let me copy the picture in again. Hold on. We know that at this value, so this is the x value, you want the f prime value right here. We know that the derivative is 0 at both of those cases. Okay, what about between -1 and 1? Between -1 and 1, there's a change. So let's look at, hold on, not between, but let's look at -1 right here. To the left of -1, what's the slope? Negative. On the right-hand side, what is it? Around the immediate vicinity here. What's the slope right here? We're looking at the, no, not the act. Hold on a sec. So instead of f prime, no, you're absolutely right. I was just writing the wrong one. Look, you're I was making it much harder than it is, right? What should it be? We need it g prime, but what is g prime? F of x. So we can literally just look at this function right here. That is f, right? So what do we know to the left here? It is positive. So we know it's positive there. But then between, what happens over here? What is this? Those are negative values. And then, right, let's do another color, I guess. What about this one right here? Negative, right? So now you look at this and you say to yourself, what's going on? What's going on? The function, we're looking at g, remember, g. G is rising, and then what is it doing? Falling. And then over here, it's still falling. So what happens at x equals -1? It's a max. And then what about here? It's falling, and then it's falling. So what is it? It's neither, because it's falling and then falling. It has to go up and then down to be a max. It has to go down and then up to be a min. This is going up and then down at -1. So this is a max, and this is a neither. Look what the question says. The question says, for each of them, justify whether it's a relative minimum, a relative maximum, or neither. So by the first derivative test, what have we found out? What have we found out? You literally write x equals -1 is the location of a what? Of a relative max. X equals 1 is the location of what? Of neither a max or min. Thank you for not letting me make it more complicated than it is. We just ran into another one of the problems, which is be very careful. Are you minimizing or maximizing f? No. What are you min-maxing? G. You're trying to find the relative mins and maxes of g, not f. Second derivative, Peter. Because we're looking at inflection point. What happens at an inflection point? The what changes? The concavity changes, which means what? The second derivative what? Derivative what? Changes what? Changes sign. The second derivative changes sign. The second derivative. And again, what are we looking at? The graph of g. Well, we know that g prime of x is equal to f of x. So what is g double prime of x equal to? F prime of x. So all we're looking for are, where is f prime of x changing sign? Where is f prime of x changing sign? So here's our picture right here. Where is f prime of x changing sign? Because f prime is g double prime. So where is it changing sign? Well, let's break this up. I'm going to break it up here, 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 and here. There's some regions for you. What is this? Is f prime positive or negative? Positive. Oh, I'm going to break it up again. Sorry. There's one more I'm going to break right here. Where else is it positive? 0 and 1, right? What about everywhere else? So we know it's negative right there. I'll keep that. So, sorry, positive, excuse me. That's positive, and I'll try to make it clearer. Highlighting is challenging sometimes, so that's positive right there. But then everywhere else, what is it? So it's negative here and. So negative and negative. So let's look at this. Where does it, at what values, at what x values does it change sign? X equals negative 2, 0, and? Does it change anywhere else? Does it change anywhere else? 1, yeah. So at those x values, what happens to the second derivative of g? It changes sign. So what do we know has to happen there at g? Points of inflection, because the concavity changes because the second derivative. But again, we're dealing with g. We know that g prime is f, so g double prime is f double, g double prime is f prime, g double prime is f prime, yes. You to do, you literally can just write, and this is good notation for you to get a handle on, dB dt when b is equal to 40 is going to be 1 over 5 times 100 minus 40, which is what? 60 over 5 is 12. And what are the units on this? I think it's grams a day, I think. And then you're doing dB, which is the weight of the bird dt, when b is equal to what? What? Units? Yeah. But look, you can say grams a day, because I think t is in days and b is in grams. So it's 1 over 5 times 100 minus 70, so that's 30 over 5, which is what? 6 grams a day. So it's gaining weight faster there. Why? Because 12 is greater than 6. So it tells you, in terms of b, what does it tell you dB dt is? 1/5, 100 minus b. So you need to differentiate this in terms of time. Before you differentiate, what might it be helpful to do? What could it be helpful to do before you differentiate this? Distribute. This equals 20 minus 1/5 b. We're going to differentiate this with respect to what? No, t, time. We're differentiating with respect to time. So if we differentiate this with respect to time, you get the second derivative with respect to time. What does the 20 turn into? 0. Nothing. Good. You end up with negative 1/5 times dB dt. Why do I write dB dt instead of 1? Because I'm differentiating with respect to what? Time. I'm not differentiating with respect to b. I'm differentiating with respect to what? Time. But what is it asking? Look what I triple, quadruple underlined right. In terms of what? B. Do we know what dB dt equals? Yeah. Yes. We know that dB dt is equal to this. So where can you plug it in? Right there. So what does that tell you? The second derivative of b dt, like this, is equal to negative 1/5 times 1/5 100 minus what? B. Look, now you have to plug it back. That's key. You find it, and it has to be in terms of what? It has to be in terms of b. If you leave dB dt in there, you won't get that point. You have to substitute it back in. This is a very common tactic. You have to resubstitute what you know. You've done this before because you did it. This is implicit differentiation. Do you remember implicit differentiation? You use it on relations. You get y prime in your answer for second derivative. You have to plug it back in. This is the exact same thing. So it's asking you, use this to explain why that graph cannot, tell me, they're saying this right here is b in terms of t. And here's your second derivative. They're asking you, why can't that be the graph? Well, here's the thing. They've made you find the second derivative. What does the second derivative tell you about the function? Concavity. So what can you tell me about the concavity of this thing? What can you just generally, what can you tell me? It's concave up, and then it turns into? So the only thing you can generally tell me is that for some of it, it's concave up, and then for some of it, it's what? Concave down. Let's go back and look at our second derivative here. This is equal to what? Negative 1 over 25 times what? 100 minus what? B. And what is B? B is the weight of the bird. So what kinds of numbers can B be? Positive and generally less than 100. But it has to be positive, right? The bird exists, so therefore it weighs something. So B has to be greater than 0. Here's the key realization. When B is greater than 0, what can you tell me about this? It's always what? When B is, you know that negative this of 100 minus B has to be what? Less than 0. So always what? Concave down. But look up here. What is that? For sometimes it's concave up and sometimes it's concave down. But what have we shown? The second derivative when B is greater than 0 is always what? It's concave down. But here's the thing. When we're assuming it can't go higher than 100. If it is higher than 100, what's the population doing if it's higher than 100? Decreasing. Keep in mind, this is time and this is b, right? So we're looking for positive b values. But look, from 20 to, like, I don't know, 40, it's concave what? Is that true? Yeah. What does it have to be? Concave down. Down. Good. That's what I like, simple answers. But the key realization is this right here. This whole thing revolves around this. That's the most important part. If you get lost, you have to ask yourself, what have they forced me to do in the other problems? It said find the second derivative and use, doesn't say use that information. Well, it does. It says use it, doesn't it? Use the second derivative to explain why. Well, what does the second derivative tell you about? Concavity. So then you look at your graph and say, oh, it's concave up in some places and concave down. But from 0 to 100, when b is 0 to 100, the graph must be always concave down. But that graph is not, so therefore it can't be the graph. We're looking for a solution. A solution means a function whose derivative is that. How many functions are the integral of that? How many functions are that thing's integral? An infinite, right? Because when you take the integral of that, what can you always add? A different what? A different constant. So to fix it at one solution, what do they have to give you? They have to give you a point. They have to give you an initial condition, a point that it goes through. Because when you add a number to a function, it just raises it up and down, right? That's all it does. So here, db dt is equal to this. So the first thing we have to do is separate the variables. What does that mean? What does separate the variables mean? Oh, come on. The dt needs to be attached to t, and the db needs to be attached to b. So how do we do that? What do I do first? We could, sure, you want to multiply times 5? That's fine, if you want to. 5 times db dt is equal to 100 minus b. Now what? Now what do I do? Oh, let's multiply by, that's good. OK. So 5 times db is equal to 100 minus b times what? Now what do I do? Yeah. So what do I end up with? 5 over 100 minus b db is equal to what? dt. Have we separated? Yes. The db is only touching b's, and the dt is all alone. Now what do I do once I've separated? You integrate. So if we integrate both sides, what's the integral on the right-hand side become? Just t plus some constant. And we'll just add one. Remember, we can just add one constant. Doesn't matter if it's both sides or one. What does the other side become? Careful. You can take the 5 and factor it out, so it's 1 over 100 minus b. What's the integral of 1 over 100 minus b? ln of what? Absolute value, 100 minus. And it's why is it negative? Because it's going to kick out that negative from the negative b. Yay! But are we done? Are we done? We can also make this. We don't have to keep it absolute value because b is between 0 and 100. The reason you make it absolute value is so you avoid. Well, we kept it just on the right. We kept the constant. The absolute value is there for several different reasons. One of them is you can't take the natural log of a negative number. But here's the thing. We don't have to worry about it because b is between 0 and 100. Because when you take the derivative of this thing, the chain rule is going to kick out a negative because of the negative b. And is this thing negative up here? So now we have this, but are we done? What do we have to isolate? What do we have to isolate? Nah, we have to find out what c is, but what do we have to isolate? B. B. But no, t is a variable, b is a, we need to isolate b. Because look what it asks you in the question. It asks you to find y equals b of t. So you have ln of 100 minus b. We don't care about the absolute value because 100 minus b is going to be positive of what? T over negative, well, negative this over plus, I'm going to call it d. Is it OK if I just call it d? Why? Because you're taking a constant and you're dividing it by -5. What is it still? A constant. Now what do? We have it in log form, so we translate it to what? E to the negative t over 5 plus d equals what? 100 minus b. So what does b equal? 100 minus e to the negative t over 5 times e to the d. What can we call e to the d? G. So we have b of t is equal to 100 minus what? g times e to the negative t over. We're not done yet because what do we still have in there? G. Someone said constant. We have g in there. How do we get rid of that g? Now we have the point. What does the point tell us? It tells us b of 0 is what? 20. So what does this say? It says when b is 200 when t is what? Oh, is it 20, not 200? So b is 20 when t is 0. Hey, does plugging in 0 for t help us out? Yeah. So we know b of 0 is equal to 100 minus g times e to the, 0. What do we know that has to equal? 20. Can we solve now? What's e to the 0? 1. So we have negative g is equal to negative 80. So what does g equal? 80. Now are we done? Yeah. b of t is equal to 100 minus 80 times e to the. That's going to be 5 points. That's like 4% of your entire exam right there. It took a while, yeah. But if you cruise through this, you should be able to do it. It's a little tough. I would say, honestly, this is a lot of work, but I don't think this is the hardest part. For me, the hardest part is this right here. This realization to me is the hardest thing to see, in my opinion. But here's the thing. Can you do part C even if you didn't do part B here? Yeah. Separation of variables. Should you guys slam dunk it? Yes, because did you practice slope fields? Yes, this is my like jump shot slam dunk, you know. I'm jumping so high that all I have to do is reach out and go down, right? Let g be that function. Is g continuous at x equals negative 3? Use the definition of continuity to explain your answer. So what's the simplest way you can describe continuity to somebody? A function is continuous if you can picking up your pencil, right? So the question is, can you do that? Can you do that? Well, f is that function and g is x plus 7. So at negative 3, you look at this function and you say, what is f of negative 3 here? It's going to be 25 minus 9, which is what? It's going to be 4, the square root of that. But then right here, that's g. What's g of negative 3? What is it? 4. It is 4. Does that make sense? It gets infinitely close to 4? Because it doesn't actually contain it, right? Because it's not there. So is it continuous there? Yes, it is continuous. Does that make sense? Because you can say it because the left-hand limit and the right-hand limit are both the exact same thing. The limit of g of x as x approaches negative 3 from the right is equal to the limit of the limit as x approaches negative 3 from the left of g of x. As you go from the left and the right, they both go to what? They both go to 4. They both go to the same value. So basically, if you graph this, if you actually just graph this, you would notice that they meet up. That's what it's looking for. What is it? This is the clinical definition of a straightforward u sub. U is equal to 25 minus. So du is equal to negative 2x dx. So what does dx equal? Du over negative 2x. So now what do you do? Now what do you do? Now you substitute it in. It's the integral of x times the square root of u. What's dx? Du over what? And what do the limits turn into? Careful. What do the limits turn into? This is the trickiest part by far. What's the lower limit? Limit is 25. And what's the upper limit? 0. Why? You have to plug. Look, these are x values. You have to change them into what values? U values. So now you flip it around. Oh, what's the magical thing that happens? What happens to the x's? So you end up with, you take this negative 2 right here and you bring it to the front, but then you're making it negative and flipping it, right? So what do you end up with? 1/2 integral from 0 to 25 because you have negative of a what? Negative of a negative, right? So it turns into a positive of what? What goes in there? The square root of? So it's u to the, can you guys do that? Yeah, it's 1/2 of 2 times, not 2, sorry, 2/3 u to the what? 3/2 from 0 to what? What's nice is when you plug in 0, what do you get? Nothing. When you plug in 25, what does 3/2 mean? It means square root cubed. So this is 1/2 times 2/3 of the square root of 25 cubed. So you have 1/3 times what? So it's 125 over. If you forgot to flip it or you forgot that negative sign, you'd end up with a negative answer, and that should be a giveaway that there's something wrong. Because what are you trying to find out? It should be positive because this thing is going to stay positive, because it's 0 to 5 times something that is positive. Just be careful.